I forget the meaning of the word like oscillation.
Okay. Okay, we will revisit that. Apart from that, the different types of motion that is clear to you now. Rectilinear motion. Tell me, rectilinear motion, what is it? Mm-hmm.
What's that?
Rectilinear motion or the linear motion. What is it? When an object will be said to be doing a rectilinear motion? Yes, Fatima?
Mm,
Hmm. Linear or rectilinear. Basically, whenever a body or a person will be moving in a straight line without changing their direction. So that is called as rectilinear or linear motion. Okay, Fatima?
So
Hmm.
when a person is moving their motion
Mm-hmm.
is called as rectilinear motion.
It is important to include in definition when the person or a body is moving in a straight line. Straight line. Okay, Fatima?
Okay.
Hmm. Then about the circular motion, what did I told you?
A position that goes like circulation like around does the
Okay.
same motion.
Suppose if you have to write this definition in the exam, so you can't go on to explain it in this manner. No, this is a like informal definition to this. We have to be very specific in defining it, particularly in exam. So whenever an object will be traveling in a circular path from a fixed distance, getting it now. So that is called a circular motion. In this animation, also you can see that this object is moving in a circular path from a fixed point. No, yes, yes or no?
Okay, so
So that is the circular motion. This is one of the example of circular motion. Wind vane that tells us the direction in which the wind is moving. So we had several other examples, like basically any object that will be moving in a circular motion, circular path, that will be said to be doing a circular motion. Further, we learned about the oscillatory motion also, right? About the oscillatory motion, what have we learned? Tell me. The object will be moving in forward and backward direction. It will be doing a to and fro motion. Getting it? Meaning that it will be doing a to and fro motion, forward, backward, like this. So we learned about oscillatory motion. Okay. So particularly we had learned about the pendulum, a simple pendulum. What do we call this structure? This yellow one is Fatima. First
you
of all,
say
what do we call this structure? This is fair. What is it called? The yellow structure here. That is called.
so
Hmm.
the pendulum.
No. The complete setup is called as pendulum. This is called
Oh,
as bob. B-O-B. Bob. First of all, turn your camera on in the class. Turn your camera
okay,
on.
so
Hmm. This is called as bob, and this is called as thread. Okay, no? There has to be a fixed length of the thread. Okay. So this is called as bob. Keep this in mind. Such a small thing, one should remember this, by the way. Okay. About the pendulum, what we have run that pendulum would be moving from its mean position, like it starts to move from its mean position and goes to the extreme position. And from the extreme position, it goes to another extreme position and then come back to its original mean position where it was resting. So when it does this kind of motion, it will be taking a fixed period of time, fixed amount of time. So every time it will be repeating this type of motion, it will take a fixed amount of time. And that was being called as oscillation. Kindly now just read this definition once again. Read the definition of oscillation only.
what's it?
Yes, read this aloud. Read this loudly.
When the bob moves from its center mean position to its extreme ends, it is said to be one complete one oscillation.
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 Okay, tell me what have you understood from this?
So, sir, when the bob moves
Hmm,
from the center
hmm.
and then the extreme position.
Okay.
It is said to be an oscillation.
Okay. Important thing to be understood here that see oscillation can be understood in two ways. If say earlier I did told you that when this bob of the pendulum is moving from its mean position to the extreme position B, from B it goes to the C, and from C it comes back to mean position A. By the help of the arrows also you can understood here. Tell me from here where is it going? It is going to extreme position B or extreme position C?
Sir,
Right now, just tell me that the where is the position of the pointer? This red pointer that you see on the screen, is it lying at the mean position or the extreme position? Where is it lying?
sir,
Okay,
mean
so
position.
first you start moving from the mean position. Now tell me where the arrow is indicating where it is going.
Sir, to extreme position.
Yeah, to one of the extreme position. Okay, and from this extreme position it goes back to another extreme position, right? Getting
Yes.
it? So for there it will just stop for a very tiny fraction of second. For a very small amount of time it will stop, and then again it comes back to now where it
Mean position.
to the mean position. So when it does this kind of motion where it goes from mean position A to another extreme positions, respectively to extreme position B and to C, and then comes back to its original position. So that type of motion is called as oscillation. What do we call this? This is called as oscillation. Okay.
Yes.
If you have
Okay, sir.
understood this now, explain all of this in terms of like just explain all of this in a proper,
Okay.
well structured definition. Define this.
Okay. So, sir, in the pendulum, the bob is in the mean position, and then it goes to one of the extreme position,
Hmm.
and then it travels to the other extreme position, and then comes back to the mean position.
Hmm. Then this type of motion will be called as
Oscillation.
oscillation, right? And this is one oscillation, right? Okay. And this must have taken some time now. The bob will take some time to do this kind of motion. So that is called as time period of that pendulum. Okay, no? Which basically says that the time taken by the pendulum bob to complete one oscillation is called as time period. Got this thing or not?
Yes, sir.
Okay. Further, we learned about two terms about the time period, like how basically we have already learned like how you can calculate time period. So we have this formula that is total time taken upon total oscillation, total number of oscillations. Okay, now further we also learned about frequency. Okay, let's just do one small question on time period. Okay, now and then we are continuing with frequency. We'll revise that. Okay. So say if I were to give a question to you, I'm going to write the question here. Okay, now from here.
Okay.
Hmm. So see that if the total time taken by a pendulum is 35 seconds and it does it does 200 and 200 and 245 oscillations. Find the time period. In short, how do we represent time period? By capital T. Okay, now you know the formula, or should I tell you the formula of time period?
What's that?
You know the formula of time period? You have written it somewhere.
No, sir.
Time period equals to total time taken, basically total time upon total number of oscillations done by the pendulum. So using this formula, find the time period. Can you define the time period for me once again? Just define the time period, what you have understood from this. Hmm.
Sir, I didn't get your question.
I'm asking you, kindly define time period. Once you will be done with definition, then you will get back to this question. Define time period.
Um,
Mm-hmm. Yes, Fatima. See, time period, as we have learned moments ago, that it's simply the time taken by the by the pendulum to complete one oscillation, isn't it? Whatever time it took to complete this one oscillation, that is called as time period. No,
yeah.
repeat the definition what I just said.
A time period is when it takes to complete one period of motion.
No, the time required by the pendulum to complete one oscillation is called as time period. Okay.
Okay.
Hmm. Now we have the given values here. Question is, if the total time taken by a pendulum is 35 seconds and it does 245 oscillations, find the time period. Okay, now find the time period. So do this question quickly.
So we have to divide, right?
Yeah, of course we have to divide now. Just put the given values in this formula. That is time period equals to total time upon total oscillation. And then you will get your value. Okay. Also try to ask questions in the class. Like today only you are there in the class, but even if all the other students are there in the class, don't feel shy in asking questions. If you're stuck in any question, you can and ask directly to me in the chat box. Okay, now there is this option. You can send messages separately in the chat box. Okay, Fatima. Okay, continue. Also, Fatima, the assignment that was given your last class, you have not uploaded the assignment from the last class.
So I was in well. That's why.
Okay, but try to do the assignments on regular basis. Okay, no.
Okay.
Hmm. See, the thing is, the reason why assignments are given now. Suppose, for example, if there was some incident, let's say something happened, or some you went to some place, you went to for a picnic with your family or with your friends, suppose. So you will not forget the memory of the picnic for a very long period of time, suppose. Why? Because usually we discuss about such things with friends and families very often for a very long period of time. So the memory of that in such special incidents, suppose some family functions or some celebration, that imprints in our mind for a very long period of time. So we tend not to forget those things. Okay. So similarly, like, it is applicable everywhere. Whenever something is discussed over and over again repeatedly, if it is discussed, if it is talked about, so we tend not to forget those things easily. So that is the reason why assignments are important. When you will learn something in the class, and based on that question, with based on that concept, when you will be practicing some questions, so it will be very effective for you. Getting it?
Okay, sir.
Hmm.
So
Done
what
with
is
this.
after dues?
What is after?
Dues. Like, what's the number after dues? 26 or 25?
26 or 25? What exactly you're saying? It does 245 oscillations. Okay, no?
Okay.
Hmm. Does 245
245.
oscillations. Yes. Okay, tell me which number you have divided, which numbers you have divided here. What is the total time given here in the question?
Sir, I have not divided yet.
Okay, do it fast. Fatima, by now you should be done. Tell me what have you put here? Time period equals to? Yes.
Yes, sir.
Yeah. What are you getting? Are you done so far or not?
Sir, almost. Just 1 second. I was
Okay.
writing the question, so it took me a while.
Oh, by the way, there was no need to write the question. Okay,
Oh,
no?
okay.
Okay. Continue anyways.
Yes, sir.
Mm-hmm. What's the answer?
Sir, is it 6.9?
6.9?
Yes.
No, no, that is not correct. Tell me what have you put in, which number you have put in the numerator? 35 or 245?
Uh, sir, where?
In the numerator, you understand the
Oh,
numerator and denominator.
yeah, yeah.
Mm-hmm. Which number you have put?
Sir, 35.
35. 35. And in total oscillation, in the question it is given as 245.
245.
Okay. So you will never be getting 6.9. You will be getting a value that will be in fact less than 1. Let me tell you how we have to do calculation. I suppose you're having difficulty in dividing this, right?
Yes.
Where you're facing the difficulty. See, first, no, whenever you have such numbers as division, first you're going to simplify the number, simplify the fraction. Okay, now you
Okay.
understand how it has to be simplified. Hmm? So basically, what we will do, we can find the HCF and then we can simplify. Whatever HCF we find, we divide the numerator and numerator with that given HCF, and then you get the simplified fraction. What I'm saying that suppose if you have 8 upon 16, this is a fraction, but it is not simplified. So we find the HCF. What is the HCF of 8 and 16, Fatima? Highest common factor is? Yes, it's 8 now. Highest common factor is 8. Getting it? You know how to find HCF? Hmm?
What, sir?
HCF, I'm asking about HCF of 8 and 16. To
Mm,
sim
yes.
Hmm. Like say you have 8 and 16. The factors of 8 are 2, 1 is starting from 1, 2, 4, and 8. Factors of 6 are 1, 2, 4, 8 and 16. The highest common factor is 8. So you divide both of them by 8, and thereby you have 1 upon 2, that is the simplified fraction. 8 upon 16 was not the simplified, you have simplified it like this. Similarly, we can go on to find the HCF of 35 and 245. So we can do it like this: 35 and 245. Okay, no? 35 and 245. So what we can do here, let's say we take 35 twos are 170. 35 threes are how much? 105. Getting it now? 105. Like this, we can do it, and basically you will find the HCF here, and you will find it to be 35 basically. Okay, no? So you'll divide both of them by 35, and you will be having 1 upon 7. So basically, the simplest fraction will be 1 upon 7 now. 1 upon 7. We can go on to divide this. We can go on to divide 1 by 7, and we'll be getting the value somewhere around 0.14. So this is the time period. 0.14 second is the time period. Got this or not?
Yes, sir.
Okay. We did also learn about the frequency. Tell me, was the concept of frequency clear? Basically, in this, I did told you guys that it's basically the number of oscillations that will be done by a given pendulum in under 1 second. Like how many times this will be vibrating, how many times it will be moving, it will be doing one oscillation under 1 second. That is called as the frequency. Okay, now suppose for example, if it does not, let's say there's a pendulum, and in under 1 second, let's say it will be oscillating, it will be doing oscillation for about, let's say, 35 oscillations. So as per the definition of frequency, where we have learned that frequency of the pendulum basically means that the number of oscillations it will be doing under 1 second. So here, how many oscillation a given pendulum is doing? 35 oscillation. The time is 1. So thereby the frequency will be what? It will be 35 only.
Yes.
And the unit of frequency is hertz. In short, it is written as capital H, small z. So frequency is 35 hertz. Got this or not? So that was frequency, and we have this formula to calculate frequency, which is basically total number of oscillations upon total time taken. Total number of oscillation upon total time taken. So based on this, I'm going to give one question to you. Just write down this formula in your copy. Frequency equals to total oscillation upon total time taken.
Okay.
Hmm. Yes, done.
No, sir.
Okay, write it. And in school, what is going on currently? Which chapter is being taught?
Sir, reproduction plants.
Reproduction in plants. Okay. Fatima, what's the update on your upcoming exams? Do you have any update?
Yes, sir. My duties are in November, like in 1 week.
After 1 week.
Yeah, it's not even 1 week actually. It's on Thursday. First is science.
Okay. You didn't told me about, I didn't got to know about your syllabus earlier.
Sir, the syllabus is transportation in plants and animals.
Transportation in plants and animals.
Yes.
Okay. Did you send the syllabus to the team?
No, sir. It's actually written in my book, so I'll send it today.
Okay. Just tell me that your exam is on upcoming Thursday.
Yeah.
Okay. Less than a week.
Yeah,
Then
less than a week.
and
And
then
the
you
chapter is transportation in plants and animals.
transportation in plants and animals. Transportation in plants and animals. What is the name of this test?
PT2.
This is PT2. Okay. I will be asking questions from this chapter to you. Okay, no?
Okay.
just to check how your preparation has been going on. Maybe after this question, I will be asking question from that.
Okay.
Done? Written the
No, sir.
formula?
No,
Okay.
sir.
Okay, Fatih.